Hello, class. Today, your teacher has brought you a special present. We're going to do word problems. Now, I know what you're thinking. Word problems. That is the worst thing on earth. In fact, when you think of word problems, you probably think more like this.
I am a word problem, and I will destroy you.
I can assure you, though, that today it's not going to be like that at all. You're going to learn tricks on how to solve any systems word problem, and I'm going to make it so easy that you won't believe it. What? No, I didn't eat this boy. He's just here for the ride. See, look, he's smiling. Shame on all of you. He just wanted to watch this video and learn along with you. All right, take out your pencils and your notes, and maybe even a calculator. Let's learn how to do word problems. And for our first word problem, we're going to talk about Allison. Allison is selling concert tickets for Dave Matthews, the most awesome musician ever. Student tickets cost $2 and general admission tickets cost $3. Allison sells 1,957 tickets and collects $5,035. How many of each ticket were sold? So you notice here I have a chart for you. And this is the way I'm going to set up every single problem. I'm going to have this chart here, and then you are going to be able to fill in these boxes. And in fact, in the end, you're going to be able to fill in all of the words in these boxes. Now, first, this is the easiest thing. You're always going to write total in the top right-hand corner. Every single problem, you're going to write total. Every one. Seriously, it's that easy. Total, right there. Everyone's going to get that one right. Next, you're going to write down what the two totals are. So look through your word problem and let's see if we can find a total. $2? No. $3? No. 1,957 tickets? Yes, this is definitely a total. So I'm going to put number of tickets, and right here I'm going to write 1,957 because she sold 1,957 tickets. So over here I would write number of tickets. Now I know that in this example it's already given to you, but in the future it won't be. All right, so that's one total. Let's see if we can find another. Our next number here is $5,035, and that would be a total amount of money that she's collected. So right here, I'm going to write 5,035, and then to the left side, I'm going to put dollars because it was a total number of dollars. Finally, at the top, here's how you come up with these two words right here. You're going to look for what the question is asking for. In this case, it's asking how many of each ticket were sold. This gives you a huge clue as to what goes to the top. Each ticket means, well, what are the two different types of tickets? If you go back here, you see that the two types of tickets are student tickets and general admission tickets. So the two things on our top right here would be student and general admission. Once again, you're always going to look at what the question is asking for and put at least one of those two things up here on the top. Sometimes it'll give you one of them. For example, one question might ask how many student tickets were sold. So student tickets would be here, and then you have to look and find the other type of ticket, which would be general admission, and write it here. If it says, in this case, each ticket, you just have to look back up to the problem and figure out what the two types of tickets are, put them up there. All right, now to fill in the rest. What is the number of student tickets that were sold? Think carefully. Go ahead. Correct, we have no idea. So I'm going to put S for the number of student tickets sold. Then general admission. How many tickets were sold that were general admission? Correct again. We don't know. So I'm going to put G for general admission. Now on to the dollar sign one. This one's fairly easy. Whenever you have one with dollars, you're going to look for things that have dollar signs in them, and that will give you a huge hint as to what's going in those boxes. We have $2 and $3. Student tickets cost $2 each. So if I sold one student ticket, I would get $2. If I sold 5 student tickets, for example, that would give me $10. I know that because I would take $2 times however many student tickets I sell. So in this case, this would be 2 times S. Over here now, general admission tickets cost $3 each, so $3 per ticket. That means I'm going to take 3 times the number of tickets, which was G. That makes this 3G, like my cell phone network. Next, I'm going to put a plus sign in between these guys because I'm adding the number of student tickets plus the general admission tickets to get 1,957 tickets. And I'm taking all of my student money plus all of my general admission money to get $5,035. So I've got a plus sign there and an equal sign there on both equations. Now that we have this set up, you've done the hard part. You already know how to do substitution and elimination. But just as a refresher, let's go ahead and go through it. So can I immediately eliminate by going straight down? Well, as I've taught you in previous videos, we always want to put ones in front of the letters if there's no number there. And on the bottom, I always like to put plus signs there if there's no sign there. Just like that. And like we saw on the previous slide, we have plus signs here. So I've got 1 plus 2, that's 3, that does not cancel. 1 plus 3, that's 4, so that does not cancel. So I'm going to need to multiply either the top or the bottom row, or both, by some number in order to get them to cancel. Now, what I have taught in the past is I can take this bottom number and write it up here on the top. Then I can take this top number and write it down here on the bottom. Now, if the two signs were already the same, then I just need to change one of these to a negative sign. If they were both opposite signs, they will already cancel once they're the same number, so I would leave them alone. In this case, these are both positive, so I'm going to make one of these two negative. And again, it does not matter which one you choose. I chose the bottom one just because I had left more room to put a negative sign there. All right, now I'm going to multiply the entire row, and I mean the entire row, every single term on the top by 2. So this gives us 2s plus 2g equals 1957 times 2, which is going to be 3914. Next, I'm going to take 2s, 3g, and 5035 and multiply by negative 1. So that gives us negative 2s minus 3g equals negative 5035. For my next trick, I'm going to go ahead and do some canceling. 2s minus 2s cancels. They're gone. They've been eliminated. Let's do some subtraction now. 2 minus 3 gives me negative 1. And then here we're going to do 3,914 minus 5,035. That gives us negative 1,121. My final step is to divide by negative 1 because negative 1 is touching the g. We don't want them touching each other. That's gross. So they divide, and I'm left with g equals 1,121. What in the world does this even mean? Well, going back up to our chart, G stands for the number of general admission tickets. So that means that I have 1,121 general admission tickets. I'm going to abbreviate just to save you time and space. 1,121 general admission tickets. Now, unfortunately, if we go back to our question, it asked us how many of each ticket were sold. So that means that we have to find out also how many student tickets were sold. Now, you know, just like in all of your other elimination problems, you can take this number and plug it into either the top equation or the bottom equation. If you're having a hard time deciding which one, my advice is to always go with the one with the smaller numbers, or if you have one without any numbers in front of S or G, or whatever letters they are, I would always use that one. So, since in the top equation I don't have any number touching S other than 1, and also there's no number touching G other than 1, I'm going to use the top equation. Now, if you're stubborn and you want to do the opposite of what I'm telling you, go ahead, use that bottom equation. You will still get the exact same answer. So, as you can see, I copied my top equation. But then, instead of G, I'm going to put 1,121. It's important to notice that you have to type it in or write it into the correct letter. You have to put it in here for G for this to make sense in the end. So instead of G, I'm going to put 1,121. Everything else, I'm just going to copy. So copy your S, copy your equal sign, the plus sign, everything, 1957. Finally, in order to solve for S, I'm going to subtract the 1121. And that gives me S equals 836. Now 836, what does that mean? If I go back up here, S stands for the number of tickets for students. So 836 would be student tickets. Now we know how many general admission tickets and how many student tickets were sold. And we have answered this question. And let's take some time to check out a Dave Matthews concert right here. Nice. Unfortunately, copywriting prevents me from using any of his music, but you'll just have to think of it in your head. Excellent. Okay, now on we move to problem number 2. The cost of a buffet dinner at the Yummy Buffet for the Smith family of 6 was $61.70. The buffet costs $11.95 per adult and $6.95 per child. How many children are in the family and how many adults are in the family? Well, this one, you can see here, I don't have any words. However, in your notes, I believe they're there. Everybody in the entire room knows that this word is total. Correct. This word will always be total. You will never ever change that. Always total. Never changes. Next, I'm going to look for the two totals in this case. This one's a little bit trickier. Here, I think everybody can agree, $61.70. That's easy to find as a total. So my other total is a little trickier, probably because it's not written in words, or in numbers, I'm sorry. It's written in words. So the Yummy Buffet for the Smith family of 6. 6 is the total number of people. So our two totals are going to be 6 and 61.70. 61.70 is the amount of money. So I'm going to put cost here, or you could just put big old dollar sign if you want. And then 6 is the total number of people. Okay, next I'm going to look at what the question is asking me. Question, oh, look here, we have two questions. How many children are in the family and how many adults? So right now I'm going to check out children and adults. Since those are the two things that I need, I'm going to put those up at the top. So on top you would write children and adults. My next question is, how many people are children? Well, if you read through the question, one of the questions is asking you how many children are there, so we must not know. Otherwise, this would be way too easy and it wouldn't even be an algebra question. Next, it asks how many people are adults. Well, I don't know that either, so I'm going to put A. I do know that if I add my children and my adults, that would equal 6, because there's 6 total people. Next, let's talk about the costs. Costs have dollar signs, so here's an easy one. $11.95 per adult. So right here, I'm going to put $11.95A. And then on the other side, this is going to be $6.95 per child. So I'm going to take $6.95 and multiply by how many children we have. So that's going to be $6.95C. Again, I'm going to add my money from how many children there are times $6.95 per child. So all of my children's money that I have to pay plus all of my adult money that I have to pay is going to equal my total, which is $61.70. $61.70. Okay, now that I have this, again, I'm going to put my plus signs and my equal signs here. Next, I have to multiply by something in order to get them to cancel. So this time I'm going to write 695 up here on the top. And then on the bottom, I did not have a number here, so I could put a 1. So on the bottom, I'm going to write 1. However, since these are both the exact same sign, I need to have some sort of subtraction going on. So I'm going to make that a -1 on the bottom. This again will allow my children to cancel. All right, I think we're ready. Let's take the entire top row. That is the C, the A, the 6, every single term. And we're going to multiply everything by 6. I'm sorry, 695. Multiply everything by 695. So here we go. 695 times C. And then here we have 695 times A. Now, I know you've been really impressed with all my multiplication skills so far, but I'm going to admit this one I'm doing in the calculator, $41.70. Okay, next I'm going to multiply everything on the bottom line by -1. This should be easy. You should not need a calculator for this one for sure. 695C is negative now. The 1195A is also negative. And the 6170 is now also negative. Fantastic job. Now something should cancel. If it doesn't, you have screwed up. And indeed, 695 minus 695 is eliminated. Now we're going to go straight down. We have 1195 is negative plus 695. So that's going to give us a -5. Don't forget your A. Over here, 4170 minus 6170 is going to give us -20. A little helpful hint for you is when you've got a bunch of nasty, ugly numbers just like this, and it becomes beautiful like that, that's always a good sign. So I'm going to divide by -5, and I get A equals 4. Now, I would have known from the very beginning that if this number had been a decimal, that could not have been possibly correct. Why could this not be correct if it were a decimal? Well, I'm glad you asked. What does A stand for? Let's go back up to the chart. We notice that A stands for the number of people who are adults. So this means we have 4 adults. So we always make sure that our answer makes sense. If this had been something like 2.7, would it make sense that we have 2.7 adults? No, because short people are still entire people. 2.7 would not make any sense. So in this case, 4 is a beautiful number. 4 adults. That makes perfect sense to me. So on we move to the next one, which is the number of children. Again, you can choose the top equation or the bottom equation. It is totally up to you. I personally am going to choose the top equation because the numbers are so much easier. 1, 1, and 6 are much easier than all of these decimals here. So I put C plus A equals 6, and now I'm going to substitute up here. Instead of A, I'm going to put the number 4 for the number of adults. And this is one that you probably could have done in your head on this part, but we're going to write it all out. We subtract 4 from both sides, and we get that C equals 2. As always, we have to figure out what this 2 means, so we go back up to our chart. C means the number of people who are children. So in this case, we have 2 children. So mommy, daddy, grandma, grandpa, and the 2 kids were all part of the Smith family enjoying this yummy buffet. Now, me personally, if I were at the buffet, I would be picking this one right here, the General Tso's chicken. That would be my choice as well. I hope that you find something here that you like, because I believe your teacher is taking you here for lunch today. Congratulations. Now let's talk about my friend Cletus. Cletus was always known throughout high school as, well, he was known for his gas, and it came as no surprise to everybody that after high school, Cletus began working at a gasoline refinery. One refining system produces 90% pure or 90-octane gasoline, while another produces 96% pure gasoline. How much of each of these two gasolines should Cletus mix to produce 600 gallons of 92% pure gasoline? So if you've been to the gas station, you notice there's usually like a regular and then a medium and then a super expensive kind. And that's what's happening here. Cletus is taking the regular gasoline right here and the super expensive gasoline here and mixing them together to create a final solution, which is going to be kind of like your mid-range or your moderately expensive gasoline. All right, so just like always, we know what's here in this box. Everybody say total. That's right, but in this case, for my total, I'm going to have 92 octane. So I wrote 92 octane there. However, I should also have the word total to remind me that it is a total. Now, like I said before, this is a mixture problem, so things are going to be a little bit different. So I'm always going to write what the percentage is for the total right there. However, I will still write total because, like I told you before, that box should always say total. So just to be honest, I'm going to keep total right there. Now I need to find my two totals. One of them is super easy, and it is right here. 600 gallons. That is my total number of gallons that I have in the giant barrel where I'm going to mix the two cans of gasoline. So I'm going to put 600 right there, and it was 600 gallons. So over here, I'm going to write number of gallons. Now I'm going to kind of save that bottom row for you because there's actually a trick to these solution problems that makes this bottom row so easy. First, I have to find these two numbers that are going to go right here. Now, like I said before, we're going to mix 90% octane, or 90% pure gasoline, with 96% pure gasoline. Looking at the question, it was asking how much of each of these gasolines should Cletus mix together. So the two types again are 90% and 96% pure. So I'm going to write those right here. If you want to write octane or percent, it really doesn't make any difference. All of these problems will all be about percents if they're mixture problems. Now, how many gallons of 90 octane gasoline did Cletus mix? We have no idea. And how many gallons of 96 octane or 96% pure gasoline did he mix in? Again, we have no idea. We know that we have no idea because the question is asking us. All right, so that was easy. We put our plus sign here and our equal sign here because he is adding together the amount of 90 octane gasoline plus his amount of 96 octane gasoline and coming up with 600 gallons of 92 octane gasoline. Next, I'm going to put right here number of pure gallons. Pure gallons. Now this is going to be the easiest thing ever. This row is basically given to you already. All you have to do is write down two things in a column and you got it. Most people freak out right now and start thinking too hard and making up numbers and just going crazy. Don't go nuts. This is easy. 90% is what in decimal form? Hopefully you're not just staring at me. You said 0.90, correct? 0.90. And then I'm going to multiply by this right here. So 0.90 times x is going to go in that box right there. 0.90 times x. Boom, straight down. I'm willing to bet that you will figure out what goes here. Yes, indeed, it is 0.96 times y. Right there. So we multiplied 0.90 times what was below it to get this box right there. We multiplied 0.96 times y to get that box on the bottom. You're never going to believe what comes next. Yes, indeed, 0.92 times 600 goes right there. Wasn't that easy? Hopefully you're saying yes. The first time, I admit, is a bit tricky, but you're going to do so many of these that you will have tons of practice. All right, on we move. I will insert my addition and equal signs so we are not confused. All right, next I have to multiply that entire top row by something. And in order to do that, I'm going to choose this number right here to multiply it by. I'm going to multiply by 0.9. Or 0.90 if that freaks you out. It's the exact same thing. Now, again, these two signs are exactly the same, so I have to change one of these to a negative. I'm going to change that one. And the bottom one, I'm going to multiply by 1 because there's a 1 right here in front of the x. Again, if there's no number in front, I always tell you to put a 1. So the bottom row, I multiply by 1, which I don't really even need to write, because if you multiply by 1, that's going to give you the exact same answer. The top row, I multiply by negative 0.9 because I have a positive 0.9 there. Since these were positive, one of them did have to be negative. Now I am prepared to multiply straight across. So negative 0.9 times 1 is negative 0.9. Negative 0.9 times 1 again is negative 0.9. I almost wrote plus. Be very careful with your signs there. And then negative 0.9 times 600 is negative 540. And then the bottom again, I'm going to multiply all of these by 1. So really, I'm just copying. And then I'm going to take my 600 times 0.92. That's going to give me 552. Since it is positive, I always put a plus here so that I don't make any lame mistakes. Okay, now as long as I've done everything correctly, everything should cancel with the x's, and sure enough it does. So going straight down, I have 0.96 minus 0.9, which again is the same as 0.90. So if you want to put a 0 there to make you feel better, that's okay. That gives us 0.06y. And then I have negative 540 plus 552. That's going to give me a 12. Well, as we see, we've got 0.06 touching the y. I don't like them touching each other because that's kind of gross. So I'm going to do 12 divided by 0.06. And that's going to give us 200. Now, what in the world does that 200 mean? Go back up to the chart. Find your letter Y. So Y stood for the number of gallons that are 96 octane. So we've got 96 octane gallons. So if we have 200 gallons of 96 octane, next we need to figure out how many gallons of 90 octane there were. Again, I get to choose. Do I want to go to the top or the bottom? I'm going to choose the top equation because it is so much easier than the bottom one. And probably you've already figured this one out in your head. We're going to substitute 200 in place of y, and then subtract the 200 to get our answer for x. So we have x is 400. We have to figure out what in the world does x mean, so we go back up here. X is the number of gallons that are 90 octane. So I'm going to write 400 gallons of 90 octane. And there you have it. Finally, we're going to just make sure that our answer does make sense. So 200 gallons of 96 octane plus 400 gallons of 90 octane would give us a total of 600, which is what we were looking for in the beginning. And this totally makes sense. Okay, let's talk about my friends Max and Emma. Max and Emma go to a restaurant. Max is going to order 2 tacos and 3 enchiladas, and Emma is going to order 3 tacos and 5 enchiladas. One bill is $7.80. That's going to be Max's bill because he's ordering less stuff. And then the other bill, that would be Emma's, is $12.70. They are eating in Utopia, which is a fantastic tax-free country, so we don't have to worry about any taxes here. How much did each taco and each enchilada cost? So everybody, on the count of 3, you're going to say what's going in this box right here. 1, 2, 3. Total. Yes, total was correct. And now we have to find the 2 totals, which should be fairly easy. It's not 2 or 3 or 3 or 5. It's got to be the $7.80, which goes there, and the $12.70, which is there. Like I said before, the $7.80 goes with Max, so I'm going to put Max right here. here, I've got $12.70, and that's going to go with Emma. So I'm going to write Emma right there. Now, as always, we're going to look to see what the question's asking for and put those two words right here. So the question is asking, how much did each taco and each enchilada cost? So that makes it really easy. One is going to be taco and one enchiladas. So Max, when he goes, he's going to order 2 tacos and 3 enchiladas. Now, since we do not know how much a taco costs, we really don't know what to put here except a T. However, instead of just 1 taco, he's getting 2. So I'm going to put 2T. Then, since he's ordering 3 enchiladas, and we don't know how much an enchilada costs, I'm going to use E for enchilada, and he's got 3 E's right here. We're going to put a plus sign there and equals. Next, Emma, I'm sure you figured out, right here has 3 tacos. So I'm going to put 3T there. And then over here, we've got 5 enchiladas. So I'm going to put 5E there, put the plus sign and equals. So, as usual, I'm going to clear my board so I have enough room to write. Rewrite my plus and equals signs so you can see them. And now, normally, I would see if I could eliminate anything going straight down. So I've got here 2 plus 3, that's 5. That does not eliminate. 3 plus 5, no, that does not eliminate either. So I'm going to have to multiply the top and bottom by some number. I'm going to multiply it out here just so I have enough room to show you. So I always like to tell people to take this number on top and put it on the bottom, and take the bottom number and put it on the top. Then, since these signs were exactly the same, they were both positive, I have to make one of these two negative. Doesn't matter which one. I'm going to choose this one. Now I'm going to multiply that entire top line by 3. So every single term, the 2, the 3, and the 780, we're going to multiply those by 3. So that's going to give me 6T plus 3 times 3 is going to give me 9E. Next, 3 times $7.80 is going to be $23.40. Now I have to multiply the entire bottom line by -2, so -2 times 3t is going to give me -6t. -2 times 5e is going to give me -10e. And then -2 times 1270 is going to give me -2540. So we're going to add straight down. Notice the t's indeed cancel. Now I have -1e equals -2. I'm going to divide both sides by -1, leaving me with e equals 2. What in the world does this mean? Well, we go back up here to e. E is going to be the cost for my enchiladas. So that means that each enchilada is $2. Now that I have that, I'm going to take that back up into one of the 2 original equations. Again, I do not care which one I choose. I personally like the ones with the smaller numbers, so I'm going to choose the top one. 2t plus 3e, but instead of e, I'm putting a 2 equals $7.80. Now I have to do this difficult equation solving. 3 times 2 is 6. And I know that you guys are equation solving masters, so we'll go through this part pretty quickly. We're subtracting 6 from both sides. 6 is canceled on the left side, leaving me with $1.80 on the right. Dividing by 2 because 2 is touching the t, and that's just gross. So I have t equals 0.90. Okay, could this answer possibly make sense? I have a decimal here, so that always makes me worried, right? So 90 cents, going back up here to what t is going to be the cost for a taco. So it makes sense that 0.90 is the cost for a taco? Yes, indeed it does, because that just means that tacos are 90 cents. Tacos. For our next problem, we have some percentages, which tells us it must be a sort of a mixture problem. So here we go. A total of $8,000 is invested in 2 funds paying 4% and 5% annual interest. The combined annual interest is $350. How much money is invested in each fund? So everybody here knows that this box already is total. Hopefully you have that one already written down. Next, I have to figure out what my two totals are. Well, this one makes it really easy. It says a total of $8,000, so one of these has to be 8,000. And that's our total amount of money, how much we invested. All right, 4%, 5%, that's not a total, but combined annual interest is $350. So $350 is going to be my interest total. So I write interest and $350. Next, I look for my question. The question asks how much money is invested in each fund. So my two types of funds are 4% and 5%. So 4% and 5% go right here. Next, for my original investment, I have to think of how much did I invest in a 4% account. Well, the question's asking me that, so I must not know. So I'm going to put X. My next box is how much did I invest in a 5% account? I have no idea, so I put Y. On the bottom, now, like I said before, this is sort of an interest problem. So, sort of a mixture problem, I mean. So, interest, mixture, it's kind of the same. You're going to mix money together this time instead of gasoline, which is a little bit less dangerous and a lot more fun. So, I'm going to take 4% times X, and that's going to be my box down here. So, don't put 0.4, that's a common silly mistake. 4%, if we move the decimal over twice, is not 0.4, it is 0.04. So right here you should have 0.04x. And then I'm going to take 5% times y, so you guessed it, this would be 0.05y. So if I add my money from the 4% investment plus the money from the 5% investment, that's going to give me $8,000. If I took my interest from the 4% investment and added that to my interest from the 5% investment, that's going to give me $350. So I clear off my screen so I have room to work. I'm going to have to multiply one of these rows by something to make them cancel. As I have shown you, always put a 1 there if there's no sign, or if there's no number. I'm going to take that 1 and put it on the bottom, and then the 0.04 and multiply that on the top. I have to make one of these negative, so I'm going to choose the bottom one just to make it easier. Multiply that whole top line by 0.04, so that's 0.04x plus 0.04y equals, and I've got to do 0.04 times 8,000. That's going to give me 320. And on the bottom, multiply all of those by -1, so that's 0.04x is negative, the 0.05y is negative, and the 350 is also negative. As usual, something should have eliminated. If it hadn't, I would know that I had screwed up. So here I've got 0.04 minus 0.04. Those do indeed cancel. Going straight down, this gives me negative 0.01y and negative 30. I divide both sides by negative 0.01 because I don't like them touching each other. And when I do that, I get 3,000. 3,000 seems like an awfully big number. Does that make any sense? Let's find out. So going back up here to y was the investment that I put in my 5% account. So this would be $3,000 in the 5% account. Does that make sense? Well, yes, I had $8,000, so putting 3,000 in one account makes sense. So I have $3,000 in my 5% account. Next, I get to choose which equation I want. I'm going to pick the top one because the numbers are so small. I don't know what x is, but I sure do know that y is 3,000, so I'm going to put a 3,000 here in place of y. I subtract 3,000 from both sides, which you have probably already done in your head, to figure out that x equals 5,000. Going back up to the top, X is the investment in my 4% account, so this means that I have invested $5,000 in my 4% account. And we have solved that problem. That's what the floor looks like on my house. It's so messy, I need to clean all that up. Speaking of money, you strike it rich and find some coins on the ground. They are worth a total of $3.30. They are all quarters and dimes. You have two more quarters than dimes. So here we go. We're going to find our two totals. All right. This one's easy. There's a total of $3.30. By the way, that box right there is total. I kind of figured you knew that. So $3.30 goes right there. And that is my total amount of money. So I'm going to put money right here. Got a little carried away there. Got a problem. I can't see what the other total is. So let's just ignore it and let's go ahead and figure out what the two things are on the top here. So this question is going to ask us, how many of each coin do I have? Well, I've got quarters and dimes, so my two questions here would be quarters and dimes. So I don't know how many quarters and dimes. I still have a big problem here. I don't know what another total is, but I do know that quarters are worth 25 cents, so it would be 25 cents per quarter. And dimes are worth 10 cents, so it's going to be 10 cents per dime. Now, we come to a big problem here. We only have one total. And the reason why this is because up until now, we've done all elimination problems where everything was in standard form and we had two totals and life was great. Now we have this issue where we only have one total. A common sign that you should look for these substitution problems is a sentence that says something about more than, less than, something like that. Older, younger, heavier, lighter, something that means more or less. So in this case, we have this sentence that says you have two more quarters than dimes. So here's a huge, huge helpful hint that I have for you. I'm going to draw a whole bunch of coins here. Now I know this is a fantastic drawing. Just hang in there with me. All right, so here's a pile of coins, here's a pile of coins. One of these is quarters and one of these is dimes. This is not drawn to scale. Either one of these could be quarters and dimes, despite the fact that I wrote this one kind of fat and I drew this one kind of skinny. That was not intentional. I'm just a bad drawer. All right, so I know I have a stack of dimes and quarters here. I just have to figure out which one is dimes and which one is quarters. So this thing here tells me I have two more quarters than dimes. So looking at the two stacks, the taller of the two must be quarters because I have two more quarters than dimes. So I'm going to write a Q right here and a D for dimes right there. Again, I just kind of got lucky on which stack was the skinny stack that I drew. I'm just not a good artist. So here I notice that my dime stack is a little bit shorter than my quarters stack. So how much shorter is it? Well, it's 2 coins shorter. So in order to make these equal, I would have to add 2 coins to the dime stack to make them equal sizes, to make the quarter stack have as many coins as the dime stack. So for this equation, I would have Q equals D plus 2. Look at that, we already have the equation for us. So for my number of coins, I've got Q equals D plus 2. All right, so again, my hint is whenever you can only find one total, it's not a mixture problem, look for the word more or less, younger, older, fatter, skinnier, anything that means more or less, and then do this little drawing. This drawing has saved my students and really helps people to be successful with this. So I strongly recommend this drawing right here. Now it's time for the easy part. We're going to do substitution. Again, if you really hate substitution and you just have to do elimination, you could subtract d from both sides and get it to uh, equal to 2 so that you can do some elimination. I, however, think you probably should have some practice with substitution, and also this is just way easier to do right now with substitution because it's already set. So I'm going to substitute in place of q, I'm going to put d plus 2. So I'm going to write that entire top equation exactly the same way it looks, so 0.25, but instead of q, I'm going to put an open set of parentheses plus 0.10 d equals 330. So right here in place of q, I'm going to write d plus 2 because we said right here that q is the same thing as d plus 2. In my parentheses, put a d plus 2. Okay, next, we've actually done the hard part. Now we just have to distribute. So 0.25 times d right here, and 0.25 times 2 goes right here. Now we're just going to copy all the rest. Don't even think about it, just copy. Next, you're good at combining like terms. Here you see I have two different sets of d's on the same side of the equation, so I'm going to add those together to get 0.35d. Now $3.30 minus 50 cents, that is going to give us $2.80. And I'm going to copy down my 0.35d. Divide both sides by 0.35. And that gives me that d equals 8. So what in the world does that mean? Going back up here, d is the number of coins that are dimes. So this means that I have 8 dimes. Right now, I don't know how many quarters I have, so I'm going to go back up here. I get to choose the top and bottom equation. In substitution, I always pick the one that I have circled because that's going to make my life a whole lot easier. Instead of d, I'm going to put 8 because 8 equals d. We said so right there. Copy down the rest. So I've got that q equals 8 plus 2, so q means 10. Q is the number of coins that are quarters, so this is 10 quarters. Looking back, we remember that the question told us we had 2 more quarters than dimes, so looking here, I have 10 quarters and 8 dimes, so that is correct. If I wanted to check my answer to make sure that I was absolutely 100% right, I could take 10 quarters, so that's going to be 10 times 0.25, and I have 8 dimes, so that would be 8 times 0.10, and multiply these, multiply those, add them up in the calculator, and that gave me $3.30. If we look back up to our total, it told us that we were going to get $3.30. So we know that our answer here is absolutely 100% correct. We have 8 dimes and 10 quarters. Those are not dimes and quarters, but that's the best I could do. I don't actually have any dimes and quarters myself. All I have is really ancient coins from the early 1900s. Next, and finally, let's talk about my friends Bubba and Cletus. Bubba and Cletus are sitting here on the park bench just looking at the squirrels, feeding the birds. They're talking to each other. The sum of their ages is 157 years. Bubba is 9 years older than Cletus. We're going to find out how many years old is each person. Because it's rude to ask them how old they are, we're going to have to do some algebra. So I'm going to give you a chance here to go ahead and see if you can do this on your own. You can go ahead and hit pause. Otherwise, just go ahead and just keep staring at the screen. All right, I'm guessing that everybody in the entire room, oh, I'm hoping and praying, everyone in the entire room knows that this box is total. That's correct. And next, I've got to find one of the totals. Well, we have right here that their total ages would be 157, so I could put 157. This is going to be the sum of their ages, so I'm going to write sum. Now I'm stumped again. I cannot find another total, but that's okay. I'm just going to go to the question here. The question says, how old is each person? This gives me a clue as to what should go up here. Go ahead and write in what you think should go there. My hope is that over here you have chosen Bubba, and right there you have chosen Cletus, because Bubba and Cletus are the two people. Now, I don't know how old Bubba is, and I don't know how old Cletus is, so I'm going to be stuck with just putting letters there. I do know that the sum of their ages was 157, so I can add them together and set it equal to 157. Now I'm kind of stumped. I have that same problem that I did last time. I don't have another total. So I'm going to look at this sentence right here. Bubba is 9 years older than Cletus. Well, in English we use the word older, but what that means is more years. So if you were doing this in Spanish, for example, you would say that Bubba has 9 more years than Cletus. And that's what we're really looking at. We're looking at the word more, in this case older. Older, since it means more, means I'm going to do a substitution problem. So really you're talking about the difference of their years. So I write the word difference there. That word really not that important, but I'm going to put difference. So let's pretend that Bubba and Cletus have kept all of their birthday cakes from the time that they were first 1 year old until now. There's a big stack of cakes. Some for Bubba and some for Cletus. We don't know which stack belongs to which person, but they're the stacks of cakes. Now we know that Bubba is 9 years older than Cletus, so which person should have the bigger stack of cakes? Hopefully you said Bubba. Since Bubba is 9 years older than Cletus, he's going to have the bigger stack of birthday cakes. So that means this stack of birthday cakes belongs to Cletus. So right here, Cletus is feeling a little bit jealous, and so in order to make everything equal, we're going to have to add how many cakes to Cletus? Yes, that's right. Cletus' stack has to be added 9 more cakes. So we've got Bubba's stack equals Cletus' stack plus the 9 extra cakes that we had to add on there to make them both equal. So over here, I'm going to put B equals C plus 9. Now I have two equations, and as you see, we can do substitution because B equals C plus 9. I can substitute C plus 9 up here in place of B. So in place of B right there, I'm going to put C plus 9 right here. So I took that one and substituted. And then it's going to be copying now the plus C equals 157. So you know what to do next. We've got two C's there. These are our like terms. And I always tell people to put a 1 in front if there's no number there. So we're going to put a 1 here. We've got 1 and 1. That's going to give us two C's. Copy all the rest. Subtract the 9 from both sides. And divide by 2. I know, again, I did this very quickly, but you guys are equation solving machines, so I know you're okay with that. All right, C stands for the age of Cletus. So 74 years old is Cletus's age. Now we're going to plug that back into what we circled here originally, B equals C plus 9. And instead of C, I'm going to put 74. means our friend Bubba is 83 years old. So does this make sense that Bubba is 83 years old and Cletus is 74 years old if their ages add to if their ages add to 157? Yes, indeed it does. Perfect. So there is our answer to the Bubba and Cletus problem. All right, so let's review what we've done so far. Back up here, we learned that word problems aren't so scary after all. We set up this chart. In the top right, we always put the total. We write down what the two totals are and then label them on the left side. Up on the top, we look at what the question is asking. In this case, it was each ticket, so we put the two different types of tickets. And each problem worked out pretty much the same way. Our two totals were there. The labels for the totals on the left. On the tops, we put what we were looking for. Then we came to this solutions problem where we made a mixture of two different things. We put what the mixtures were on the top, and then we multiplied straight down to find the bottom line. So 0.90 times x was 0.90x, 0.96 times y, 0.96y, and 0.92 times 600 right there. We did more problems. This time, in this case, we had to multiply both the top and the bottom by something, but that's okay because it was about Mexican food and it was yum. We also had questions where we had no total, which was more like this one right here. When we didn't have a second total, we looked for the word more or less or older or heavier or taller or something that means more or less. So when that happens, that's going to be a substitution problem, just like the one with the quarters and the dimes, as well as the one that we just did about the sum of the ages. When that happens, we make a little drawing here. We make one taller than the other and then figure out what we would need to add to the other one to make them equal. This gives us our second equation. Oh, unfortunately, that sound means that our time together is up. Be sure to thank your teacher for giving you this wonderful gift of understanding how to do word problems, particularly with systems of equations. Don't feel bad though. You can always ask your teacher to have me come back again and explain another lesson to all of you. Thank you so much for having me here. Have a wonderful day. Goodbye.
Goodbye.